Hello, I'm Christopher. I'm going to be trying to show you how to do or some practice problems from the ACT. These problems are all taken from the ACT website, so take from that what you will. Some might be altered, but they're basically the same problems just to kind of help you out and see a step-by-step process of how they're going to work. So let's try to do one with that. A couple things to keep in mind. I'm not I assume, or I'm hoping that you all know that how to do the basic algebra and geometry that's required for this test. And yeah, I mean, this is not me teaching you how to do these things. This is me teaching or going through this test with these problems, and hopefully helps you see an alternate way of thinking about problems in general. One thing to keep in mind is that I'm not going to be here this whole time. I mean, with the webcam and whatnot, I that's just how it's going to be. I'm going to be doing the problems, and if I do have something to say or a concept that I feel like I can't explain with my writing, I'll talk. I'll talk on the webcam. I'll see how it goes. But let's just kind of try to get into it. So with the first problem here, I have a car averages 27 miles per gallon. If gas costs $4.04 per gallon, how much would it cost approximately to travel 2,227 miles? So first things first here is that we know we have three distinct variables here. We have m per pg, miles per gallon. We have the gallons, right? And then we have miles. Sorry about my writing, by the way. But I hope those three variables are kind of distinctly known, because later in math, if depending on how far you go, using units as a kind of way of showing you how these problems should end out is helpful. So right now we're trying to find like how much the trip would cost. But to first kind of see that, we have to know how many gallons it takes to travel 2,227 miles. So let's kind of switch to color here. We know the miles per gallon of the car. We don't know how much gas it's going to take, and we know how many miles you want to drive. Now, I don't know if you noticed that, but I set it up in a specific way with these units, so this equals that. So if you were to multiply this by this, these are the same. The miles will be the same. So this equation adds up. So I have the miles per gallons right here, this unit, the gallons, this unit, and then the miles there in that unit. So if we just divide it out, it's going to come out to be x is equal to 101 gallons. Right? Now we're not done there, because if you notice, the problem's not asking how many gallons it takes. It's saying how much would it cost. Cost there. Not like that. Cost is the important word there. Cost. So, but they give us the cost of the gallon or per gallon. So we're just gonna multiply that out real quick. I don't recall what it was exactly. Let me check on my calculator on the side over here. It comes out to be $408.04. So let me just kind of write that out real quick. Price, money equals $408.04. Basically, right? So that is, in essence, is the answer to that problem. But, just kind of switch here for a second. I hope I hope I made it or I hope I clarified the fact that it's important for this thing right here is important in the future. That part right there, little arrow, but it's important. It's important for the fact that it when you can't kind of visualize how a problem connects to each other, if you use the units, you will be able to see how these parts connect. Because I feel like that's the trickiest part of this problem here. connecting all these things, but just a little side note there. So let's go to problem number 2. And that I just created slides just to see if we need extra work, and then, or if we needed to show some extra work there, I would. See, first example, like this problem here. This problem has a little example that takes up a lot of the room. So this whole deal here, figure 8, and all right, that's basically telling you. So let's kind of just go through the motions here. The ABC, so this angle right here, 2, is equal to DFE. So these two are the same. And then BAC, so BAC is this one, and then FDE are the same. D and F are on the same line segment as B, so these are all on one line. And then line AD, let's go, I guess yellow, AD is equal to FB, right? So it's important to note. Sorry, it's like a whole mumble of colors, but I hope you kind of understand what's going on here. Basically, what this is trying to show you is that these two triangles are congruent. So let's get back to it. So what that does for us is that we can make a ratio to find out this missing value of AD. Or of AB, necessarily. Sorry. AD is coming up later. So right up there. That's the whole thing. But let's get back to it. So we know we can choose what one we like, but basically you're doing this. FD over DE is equivalent to AB over AC. Right? So that's basically the whole problem. After that, it's just plugging in numbers to get the values you want, but let's go through it. Right? So, and plus, by the way, we're not trying to find, this doesn't help us yet. It'll help us out later. But we know what FD is, which is 6. We know that DE is 12, is equal to, and let's kind of change the color there for this side. AB, we don't know, so I'm gonna label that. I'm just gonna keep it AB line segment over AC, which is 20. Now, if I hope you can kind of tell, but this 6 over 12 is 1/2, and that's, or no, not one. That is equal to AB over 20. Now if we both do that right there, we're going to get AB equal to 10, right? So I feel like the biggest mistake here, I feel like the biggest mistake here is that people stop. They just stop thinking, okay, I got a value, I'm done. You know? So that is the mistake here. And I feel like that's what this kind of question is meant to do. Because what they do on these type of questions is they sometimes leave that type of answer there for people who stop. They will leave they'll leave AB equals 10. They'll put that as a multiple choice answer, and people will put it because it's just they got an answer. So the important thing is really read the question. Make sure you're not missing this thing. So let's go back. So let's go to the next page. We know that let me just kind of remind everybody that AB is equal to 10. Now, if we go back to the image right here, we see that the AB, we know part of AB, which is FD, which is 6, right? So that leaves 4 centimeters left that aren't done, right? And since we know in the equation right here that AD is equal to FB, that these have to be equivalent to each other, right? It can't be AD equals, it can't be that AD equals 3 and FB equals 1, or whatever it is. Let me just double check. Yeah, it can't be that FB equals 1 and then 80 equals 3, because these things right here, this, they have to be equivalent. So that means 80 has to equal FB, which means it has to be 2. Because 2 times 2 is 4. Right? So that's basically the answer to the question. Move back there. That FD equals 2, and or sorry, my bad. Let's kind of get rid of that. AD equals 2, and also FB equals 2. That's important to know, but this is the one you want. So yeah, that's the answer to that question. Let's move to number 3. Now, going back up to this angle. We have 2 different equations and 1 boundary, right? Or 1 condition, which is important to realize. So let's go down to the math here. We have that these 2 are the equations, and this one's the condition, right? X has to be greater than Y. That's the condition, right? So, I apologize. Sorry. What we have here is that we need to make these 2 equations equal to each other. Now, let's see here. We have 2 equations of x, y equals 144, and then the separate one of x plus y equals 30. So what here I'm going to do is I'm just going to make a decision to, sorry, that tree looks like a mess, but, and the y too, but I'm going to make a decision to use the first equation here. Highlighter. I'm going to make it into an equation that's helpful. So I'm going to make it y, not use that color, use black again. Y is equal to 144 over x, right? So what I'm going to do here is I'm going to plug this value into the y there, right? So it becomes x plus y, which is 144 over x equals 30. Now, let's go switch that up. This value, this x right here isn't helpful to me. So what I'm going to do is I'm going to multiply both these sides by x. Oops, there we go. X, right? So that makes it turns into x squared plus 144 equals 30x. Now that's a nice equation, and you'll see why. If we bring this side over, it's going to become x squared, and now I'm going to change the color just because it got minus 30x plus 144 equals 0, right? So now you see that this value changed. I hope that's noticeable. Now what we have to do here is we have to, what's it called? We have to factor. Now there are 2 methods to do this. I'm going to leave the method I'm not going to use on here, but I feel like it is the most accurate way of factoring, but it's just the most tedious as well. So let me just kind of write it out here for you. It's going to be negative b plus or minus square root of b squared minus 4ac all over 2a. Right? So in this case, for this kind of value, let me write this. This right here, this one, or let's write it like this. A x squared minus bx plus c equals 0. So, what's important to note here is that all these values here would be plugged in. So for instance, for this problem, I put 30 in for the b's. 1, since there's no coefficient in front of x squared, I'd put 1 for the a's. And then for the c's, I'd put 144. right? Now, I hope you can see that it would work. I hope that you can visualize that in your head, that this would work. This equation is proven right. It has been proven and it works. But I don't want to be multiplying 4 times 144 and then 30 squared minus whatever 4 times 144 is, taking the square root of that, and then once I get that answer, plus or minusing it times negative b and all over 2a. I don't want to do that. And I know you don't want to do that, especially since on the ACT, you don't have time for that. You just don't. You have a minute per problem at the most, and this is not going to do it for you. So let me kind of skip to the next page here and get to work. So let me just, we have x squared minus 30x plus 144 equals 0. Now, I don't know, I use one method of factoring usually. That's the diamond method. Yeah, the diamond method, I believe, is what it's called. I know there are other YouTube videos helping with this, so feel free, if you don't understand it, to go look over there. But basically what it is that we're finding two values here, I guess here, and here, to add up to here. So this is how the diamond method kind of works. We find two values that multiply to the first term, which is pretty simple. It's just x and then x, or negative x and negative x, but that's not important right now. And then the next term we have is 144. Now, here's where it gets a little tricky. Since there's no coefficient on this side, we don't have to worry about this side as much. But we need to find two numbers that multiply to be 144 and also add up to be negative 30. Now, I know this. I don't want to make this video super long, so I know it's going to be there 24, and 6. Those numbers multiply to be 144 and also add up to be negative 30. So that's just to save you time, right? If you ever, if you ever have an issue with that, the easiest kind of thing is to, what are the factors of this number here? And always try to be towards the middle of it. The middle have the biggest numbers, right? So if you're trying to get the same thing, but this says 225, this little thing right here is 225 instead of 144. It's 15 times 15 is 225, and I also know that they add up to 30. So it's also kind of important to know your perfect squares and that kind of stuff. But anyway, back to it. So this number is negative, so I'm going to make these both negative, negative 24 and negative 6. So it turns out to be x minus 24 and then x minus 6 equals 0. Now don't forget that there was a condition that x has to be greater than y. So I'm going to use the big number for this one. So I'm going to make it x equals 24. Now we have the equation over here of y, or x times y equals 144 there. So I'm going to move that back over here. So I'm going to make it, let's see, let's do the different one. 24 times y equals 144. Now we know the answer to this, y equals 6, because that's what we know. We know that from over here. That there. Because we know 24 times 6 equals 144, right? So that makes sense, right? We have y equals 6 and also x equals 24. Done, right? No. Now, again, the ACT is, at least from what I've seen from it, they like to do this kind of thing where they make you go through a whole process of things and make you feel like you're done, but you're not. There's one little extra thing that they want you to do with that information. Not just get the information, but do with it, right? So we know that it's asking for what's x minus y. So we know that x minus y equals 18. 18. And that's your answer, right there. That is your answer. X minus y equals 18. I hope I made that clear. I know the factoring thing, I didn't go into depth about it, but no, I guess let's do this. Know that these numbers multiply, and then you add these numbers. That's just how that diamond method works. Now, it'll get more complicated with bigger polynomials, but that's just how it is for this one. So let's go to the next one here. Okay, this one's pretty simple, but let me just kind of go through it. So we have, if we just kind of divide it out, it's 16 times 2 to the m equals 4, and n equals 8, so it's going to be 8 minus 7. Now this is the one I did alter a bit, because it used to be n minus 8, so I thought it was a little bit too easy, but let's just kind of get into that. So 16 times 2 to the m equals 4 to the 1. That's basically what it turns out to be. So if we divide both sides by 16, we get 2 to the n equals 4 over 16, which equals 1 over 4. Now, it's important to know, so 2 to the 1 equals 2, 2 to the 0 equals 1, 2 to the negative 1 equals 1/2. So, okay, so in this case, I feel like with that kind of pattern, you can tell that n is going to equal negative 2 here. Negative 2. Now, that one is fairly simple. It took legit 2 minutes to do, with me showing you and and explaining it how to do. So this problem shouldn't take you more than about 30 seconds to do on the ACT, hopefully. I wanted to change it for the fact that I thought maybe I could make it to the problem I wanted to, but no, I really couldn't. But yeah, I feel sometimes they're not going to give you n equals 8. Sometimes they're going to give you 16 times 2 to the m equals 4 to the n, and it's going to be your job to figure out what's m equal to and what's n equal to for the equations to be equal to each other. So keep that in mind, because if you didn't notice here is that they made these all powers of 2, and that's what they're usually going to do. Make it powers of 3 maybe sometimes, not, they wouldn't be anything crazy like that, because 2s are usually pretty simple. But yeah, I just wanted to make sure that's known to keep it. But let's just keep going to the next one. Alright, so yeah, I believe this is the last problem, and in the figure below, point A and point B are on opposite banks of a small stream. Point C is on the same bank of the stream as point B, and approximately 18 meters from D. The measure of CBA is 45, the measure of BC is 60 degrees. Yeah, so the picture basically shows you that. Now, little disclaimer here, that you're not really going to get that far with this problem unless you know the law of sines. That's basically how it's going to have to go. Yeah, that's because, as you can tell, if you triangles have to have all interior angles be equal to 180 degrees. So we know that 45 plus 60 is 105, and 180 minus 105 is 75 degrees. So we know that, let me show you right now. The triangle here should turn out to be 45, 60, 75, and then this side is 18. So let's make that 18, right? And this is B, C, and then that's A, right? I just wanted to put the picture there so it makes it feel more of an ACT kind of environment, but that's where we are right now. Yeah, so if you know the law of sines, this problem's quite simple. we're trying to find x. Basically, they put a question mark, but that's basically what I use when I use for an unknown variable here. It's just a force of a habit, I would say. So yeah, so I guess let's go through the law of sines. So basically what the law of sines is, just for a refresher, is sine of A over A equals sine of B over B equals sine C over C, right? So right now we know two of them. We know that, let's see, we know sine, let's change the color here, sine of 75 equal to A, which is 18 in this case, is going to be equal to, well, let's check. We know we want this angle right here, which is we know is sine 60, and we don't know this, right? Yeah, so if you do the math here, you're going to find out that x is equal to, or you just multiply it out, you're going to find that the x is going to be equal to 18 sine 60 over sine 75. Now, I know I skipped a step here. I know I skipped a step of showing you both sides, the times x, times x, times x, you know, and then multiplying both sides out for this side to be equivalent. But I also stopped here because that's where the ACT problem stops. It doesn't want you to use the calculator for that. It doesn't want that. It doesn't want you to use your calculator to find the values of the exact values of both of these things. It just wants you to leave it like there because basically you've shown you know what to do. You've shown what they expect of you, to know the law of cosines and to be able to apply it. Now, what's nice about the law of cosines is the way I wrote it probably was the worst way you could write it. Is if I was to do it again, I would write it instead with these, let's see these values right here, right there. You can make it so it's B over sine B is equal to C over sine A, so let's kind of just write it out real quick. So that, just a little side on the side here, B equals sine B equals C over sine C. So that's also a possibility. It doesn't matter. Now, what I didn't do in this problem is I didn't see which where I wanted the x problem to be, but that's my fault. That's just, and if that just made it one more step. It didn't change the value of the problem. So we know that x is going to be whatever value that turns out to be. But yeah, that's the answer to that problem. There's not like the other problems where there is some other question it wants you to know. It's just basically straight up asking you what that problem is. Now, I did try to go slowly and try to go very methodically through what these tests expect you to do, but it also is important to realize that this test isn't a lot about time management. And if you're not managing your time correctly on problems that you should be doing quickly, then you will fall behind, especially on problems that do take more than a minute to do. It's important to realize that. So, say this problem you can do in under a minute. This problem here, you can do in under a minute. Let's keep going. This problem here might take you a minute, a little bit over a minute, just on all the work you need to do for it. And all the guesswork for this one right here to kind of factor it out, that might take over a minute. That's understandable. This one could take you over a minute. Shouldn't take you over two. Same with the other one, it shouldn't take you over 2, but it could take you over a minute. This one shouldn't take you more than a minute, you know? So I hope this was helpful. Just I feel like the biggest thing here is to kind of practice these problems, and yeah. So I think that I hope that was helpful for everybody, and I hope that was the concept of trying to learn these different things was helpful with with these kind of problems, which it's more about the mindset of time management and then also setting them up so you can do them efficiently. So I hope that helped. Have a nice day.